Electron affinity. Electron affinity is defined as the change in energy in kilojoules per mole of a neutral atom in the gaseous phase when an electron is added to the atom to form a negative ion. In other words, the neutral atom's likelihood of gaining an electron. Energy of an atom is defined when the atom loses or gains energy through chemical reactions that cause the loss or gain of electrons. A chemical reaction that releases energy is called an exothermic reaction, and a chemical reaction that absorbs energy is called an endothermic reaction. Energy from an exothermic reaction is negative, thus energy is given a negative sign, whereas energy from an endothermic reaction is positive and energy is given a positive sign. An example that demonstrates both processes is when a person drops a book. When he or she lifts a book, he or she gives potential energy to the book, energy absorbed. However, once he or she drops the book, the potential energy converts itself to kinetic energy and comes in the form of sound once it hits the ground, energy released. When an electron is added to a neutral atom, i.e., first electron affinity, energy is released, thus the first electron affinities are negative. However, more energy is required to add an electron to a negative ion, hence, second electron affinities are positive. First electron affinity, negative energy because energy released. Second electron affinity, positive energy because energy needed is more than energy gained. As the name suggests, electron affinity is the ability of an atom to accept an electron. Unlike electronegativity, electron affinity is a quantitative measurement of the energy change that occurs when an electron is added to a neutral gas atom. The more negative the electron affinity value, the higher an atom's affinity for electrons. Patterns in electron affinity. Electron affinity increases upward for the groups and from left to right across periods of a periodic table because the electrons added to energy levels become closer to the nucleus, thus a stronger attraction between the nucleus and its electrons. Remember that greater the distance, the less of an attraction, thus, less energy is released when an electron is added to the outside orbital. In addition, the more valence electrons an element has, the more likely it is to gain electrons to form a stable octet. The less valence electrons an atom has, the least likely it will gain electrons. Electron affinity decreases down the groups and from right to left across the periods on the periodic table because the electrons are placed in a higher energy level far from the nucleus, thus a decrease from its pole. However, one might think that since the number of valence electrons increase going down the group, the element should be more stable and have higher electron affinity. One fails to account for the shielding effect. As one goes down the period, the shielding effect increases, thus repulsion occurs between the electrons. This is why the attraction between the electron and the nucleus decreases as one goes down the group in the periodic table. As you go down the group, first electron affinities become less in the sense that less energy is evolved when the negative ions are formed. Fluorine breaks that pattern and will have to be accounted for separately. The electron affinity is a measure of the attraction between the incoming electron and the nucleus. The stronger the attraction, the more energy is released. The factors which affect this attraction are exactly the same as those relating to ionization energies, nuclear charge, distance and screening. Why is fluorine an anomaly? The incoming electron is going to be closer to the nucleus in fluorine than in any other of these elements, so you would expect a high value of electron affinity. However, because fluorine is such a small atom, you are putting the new electron into a region of space already crowded with electrons, and there is a significant amount of repulsion. This repulsion lessens the attraction the incoming electron feels and so lessens the electron affinity.